Hello everyone, welcome back again to our channel Coders Arcade. I hope all of you are doing good. In this video, I'm going to start with the second interview question of this Java interview series. Okay, so before starting with this, I would like to request all of you to please like, share, and subscribe to our channel if you are new to the channel, and share it with your friends and family so that whoever is learning DSA or whoever is learning or preparing for placements get benefited from this playlist. Okay, so this is Saurav today, and I'll be starting now. So let's go to our question and let's see what we have. So here you can see the second question. Guys, I have already solved the first question, the unique elements question. Okay. Today is the second question. It is about missing number. Okay. Let's read the question. Write a Java function to find the missing number in a sorted array of integers containing numbers from 1 to n. Okay. The function should return the missing number. Fine. Let's try to understand this in our whiteboard. So here is the question. Find the missing element in a sorted array of 1 to n. So let's take an example. Say array is equal to 1, 2, 3. Say I right now 5, 6, 7, and 8. See here obviously you can see that 4 is the missing number, right? Got it? So how will you do this? There are many ways of solving this question, guys, but the best way to solve this using log and time complexity is binary search. Okay, so we will be using the binary search approach. So let's try to understand how we will solve this. Fine. So I will draw this array in the form of an array so that we can analyze and try to understand this. So it is 1, then 2, then we have 3, then 5, then we have 6, then we have 7, and then we have 8. Okay, let's write down the indices. 0, 1, 2, 3, 4, 5, 6. Fine. In binary search, we already know that. Guys, this is a simple application of binary search. Okay, so in binary search, we know that we have the start point, we have the end point, and then we find the mid value. Correct? Mid equal to start plus n by 2. And we have one more formula. I hope you know this. Start plus end minus start by 2. Correct? Many of you might not be knowing this, but this is the optimal mid formula for binary search. Okay. If you guys know it, I want you to comment this in the comment section. If you guys don't know it, also comment that in the comment section. I will come up with the solution or the answer in the next video. Don't worry, guys. Okay. So for those who know, it's a comment. For those who don't know, then also you have to comment about this. Okay. So this is the formula normally start plus n minus start by 2, or you can use any one of them. So it will be 0 plus 6 by 2, that is 6 by 2, that is 3. Okay. So in that case, let's see what we have. The conditions, guys. How will you apply binary search in this question to find the missing element? There will be only one missing element. Okay. So in that case, if I take it like this, just see, try to understand. What is actually binary search? What do you actually do? We either go to the right part or go to the left part. We are searching for a number, right? In this case, we are not searching for any key. We are searching for a particular missing number. Okay. So there will be a little bit of tweak or change in the conditions. We'll do that. Don't worry. So the first condition, if I say, if our ARR of mid is actually equal to, you can see here, okay, I will write something here so that you can understand. At index number 0, you can see we have 1. That means 0 plus 1. At index number 1, we have 1 plus 1, that is 2, right? You can see here, right? 0 plus 1 is 1, 1 plus 1 is 2. Here also it is 2 plus 1, that is 3, and so on, right? But if it is not matching, that means there is something wrong with the arrangement. Understood? See, at index 0 we have 0 plus 1, at index 1 we have 1 plus 1, index 2 we have 2 plus 1, index 3 we have 5, which is not equal to 3 plus 1. Got it? So we can write a condition like this. If our array of mid is equal to mid plus 1, the value, the index, this is actually the index, okay? Index plus 1, that means everything is fine here in this place. Whenever this is matching, that means from the beginning till that part it is sorted and well arranged. Our missing number cannot be in this part. Understood? Because we are actually following this Principle, index plus 1. Every index, at 0th index we have 1. So index plus 1. Got it? If this is valid, then in the left part we don't have our answer. So we'll go to the right part. Got it? How do you go? We'll say start equal to mid plus 1. Make sense? Let's see the other one. This is the equal to part. Okay, in the equal to part we go to the next part. Let's see the other one. So what I will do is I will just write down the array again, something like this. So it will be 1, 2, 3, then it is 5, 6, 7, 8, right? This was the array, and the indexes were 0, 1, 2, 3, 4, 5, 6. The mid was 3 if I'm not wrong. Okay, now in the second case where our ARR of mid is not is equal to mid plus 1. Say let's take our ARR of 3 only. ARR of 3, the mid value. And let's try to make it equal. So 3 is the mid, 3 plus 1. How much is this? This is 4, right? So ARR of 3 is what in this case? It is 5. So 5 is not equal to 4. Got it? That means what, guys? Our missing number cannot be on the right side. Got it? Binary search, we always go to one part of the array, right? That's why the time complexity is always log of n. Understood? So in that case, our missing number cannot be on the right side. It has to be on the left side, correct? This side. So here we cannot go to this side. We will not find our missing number. Got it? So we have to go to this side only. Because here it is not validating this condition that we have written here. So we have to go to the left side. But how much will you go? That is also a question. Then if this is not equal, we have to check two more conditions. The first condition is condition number A I am writing. Say suppose your mid is equal to 0. Then we cannot go to any more left side because this is our index, right? There is no negative indexing. So if our mid is equal to 0, that means which is the missing number? Can you guys tell me? The missing number will be 0 plus 1. That is our mid value plus 1. Understood? So in case of mid equal to 0, I can return mid plus 1. Okay? Understood? Let us take one more condition. Here also you can see for 5, that is ARR of 3. Let me again write it properly so that you can understand. Understood the 0 case, right? If you are going to the left hand side, if we encounter our 0 index, that we cannot go this side because it is negative. So ultimately we have to see that this is actually the missing index. At 0 index, what is the missing number? 0 plus 1. That's why we return mid plus 1. Understood? Otherwise, let's take the same diagram and try to understand this. This is 1, this is 2, this is 3, this is 5, 6, and 7, and 8. Okay. So this is 0, 1, 2, 3, 4, 5, 6. Now, in this case, we had this, right? The first thing was mid equal 0. That is solved. You understood. We'll return mid plus 1. Second case, what if the previous element follows that property that we had? Say A of index is equal to index plus 1. Got it? Because A of 0 is equal to 0 plus 1. That is 1. A of 1 is equal to 1 plus 1. That is 2. So how will you write this here? I will say if our A of mid minus 1 is equal to mid. Let's see. What was our mid value? Our mid value was very simple. It was 3, right? We had it. Now write this here. A of 3 minus 1 is equal to mid. That is 3. Just see what happens. A of 2 is equal to 3. Is it correct? A of 2 is it equal to 3? See guys, it is true, right? It is correct, right? That means what? This side of the array is already fine. We will not get our missing number here. Then what will be the missing number? It will be between these two. What can be the missing number? It will be again the same thing only, mid plus 1. See, 3 plus 1. So here also we'll return mid plus 1, because our mid is 3. 3 plus 1 gives you 4, which is actually our missing number. Got it? Understood? So I will just give you a simple idea of the intuition once again. The first thing is, if our ARR of mid is equal to mid plus 1, then we go to the right part. Okay. The second one, ARR of mid is not equal to mid plus 1, then what do? We go to the left part, but we see one thing. The first thing is, if our mid is equal to 0, then we return mid plus 1. Got it? The second condition is, if our A of mid minus 1, if this is equal to the satisfying equation, then also we return mid plus 1. Okay, so we can combine this two with an OR operation and we can do it. Fine. Now let's do one thing. Let's simply go back to our editor, and I have already created the file. So here what I will do, I'll create the method or the function. Public static return type will be integer because we are returning the number, right? Int find missing element. Okay, then what do you take as an argument? We will take the array. Okay, and as I said, int start will be equal to 0, int end will be is equal to arr dot length minus 1. Got it? And what is the base case of binary search? The base case of binary search is while our start is less than equal to the end. Okay, I will calculate the mid. As I said, guys, remember I had told you to write in the comments start plus end minus start by 2. I will use this formula, and you guys have to tell me why is it one of the optimal formulas for mid. Okay, we have this. Now the conditions. The first condition was, if our ARR of mid is not is equal to mid plus 1, then we go to the left side. Correct? But how much? We check the conditions. If our mid is equal to 0, or sorry, the OR operator, our ARR of mid minus 1 is equal to mid, that means it is satisfying the condition, right? Then what do? You return mid plus 1, because we have got the number. In this case it will be 1. In this case it will be 1, right? This case. Otherwise it will be the next number after the mid. Got it? And where do you move? We move to the left hand side. So end is equal to mid minus 1. Make sense? Otherwise, else, where do you go? Start is equal to mid plus 1. Got it? And this will be actually the right side. Fine. And suppose, guys, we did not understand one thing. See, suppose someone is saying something like this. Say the array is given like this. Array is 1 2 3 4 5 6, 1 2 3 4 5 6 7. Do you see any missing number here? 1 2 3 4 5 6 7? Nothing, right? Then what is the missing number? For size 8, the missing number will be the last number. So it will be ARR dot length plus 1. Got it? That we have to return. Say if we did not find anything to return here, here we will return our array dot length plus 1. So if it is 7, 7 plus 1, 8. Okay. So I hope you have understood the logic. Now let's do one thing. I will create a simple array is equal to, say, 1 2 3 5 6 7 and 8. Okay, and then I will say s out missing element is plus find missing element, pass our array. Okay, what should be the answer, guys? The answer should be 1 2 3 4, right? Let's run this and see what we get. You can see, guys, the missing element is 4. This is how you can apply binary search in lots of interview questions. I hope you have understood this. Let's do one more thing. Let me just copy the same thing, and then this is ARR1 and this is ARR2. Sorry, 2. Okay. So here I will do one thing. 1, 2, 3, 4, 5, 6, 7, 8. This will become ARR1 and this will become ARR2. So in this case, 1, 2, 3, 4, 5, 6, 7, 8. There is nothing missing. So obviously, if it is length 9, then it will be 9 is missing, right? Let's see if it is working or not. See here, even that is working. Missing element is 9, the last element. Got it? Clear? So I hope you guys have liked this. If you have any doubts regarding the question or any logic or the intuition, you can get back to me in the comment section. I'll be very happy to clarify those doubts. Okay. I hope you liked that, guys. If you really liked it, I want you guys to subscribe. Okay. That is the least motivation that I get from your likes, your comments, and your views. Thank you so much for watching, guys. Till the next time, till the next problem statement. This is Saurabh signing off. Bye bye.